For the following truth table, write the canonical sum of products equation. Simplify, then write the canonical product of sums equation. So we're going to start out by converting this truth table into a canonical sum of products equation. And we're going to do that by looking for all of the ones in the output and determining the inputs that make that up. So for the first part, q is equal to 1 when x, y, and z are all 0, so we're going to write x prime, y prime, and z prime. And then we're going to put an OR for the next one, so q is also equal to 1 when x is 0, y is 0, and z is 1, so x prime, y prime, z, and then so on. So for 0, 1, 0, we're going to do x prime, y, and z prime. Then we're going to skip that first 0 there, we're only counting the ones. So we're going to skip over that 0 and go to that 1, which is x, y prime, z prime, skip the next 0, and then that second to last 1 is x, y, z prime, and then finally x, y, z. Okay, now we need to make the simplest possible sum of products equation out of this, so we're going to be grouping these individual parts together and simplifying each part one at a time. That's the way I like to do it. Okay, so this first part, both sides are equal except for that z prime and z, so we can just factor out the x prime, y prime, and then make inside the parentheses z prime or z. Then for this second part, the only thing that's the same is the z prime, so we're going to factor that out, so z prime and then parentheses x prime y or x y prime. Then this xyz prime or xyz, that's just going to be xy on the outside and then z or z prime. Okay, so now we have these three parts, we're just going to combine them back together and then simplify it. So this first part, x prime, y prime, and z prime or z, that's just going to simplify to x prime, y prime. Then the second part will just simplify to z prime. And this third part will just simplify to xy. I want to talk about how the second part simplifies into z prime. Now if you look at all parts of the equation, x prime, y prime, or xy, and then it would be ORed with z prime and x prime or y, x prime and y, or x and y prime. That's every combination of x and y that you can get, except one of them just has z prime in it. Now if z was 0, that z prime would, make it true, and then what would also have to be true is x prime y or x y prime, which would be an XOR gate of x and y. And let's say that wasn't true, then the only other alternative is being x and y are both false and x and y are both true. And if one of those are true, it's just going to be set true anyways, so it actually doesn't matter if x prime y or y prime x are true, as long as z prime is true. So that's how it simplifies right there. Hopefully I explained that well enough. Now we need to find the canonical product of sums equation. And to do this, we're going to look at the zeros of the output instead of the ones and find their inputs. So the first 0 has the inputs of x is 0, y is 1, and z is 1. And because the output's 0 for that line, we're going to invert all of the inputs on there. So we're going to write x plus y prime plus z prime. And the second 0 is 1, 0, 1, so we're going to do x prime or y or z prime, and then we're going to AND that term with the other one. And that's how you get canonical product of sums equation. Now we need to describe in words what canonical means. And I have the answer to that. Canonical means a fully expanded form of Boolean expression where every term includes all variables. So a non-canonical form would be something that's simplified, something that is the most efficient for logical gates, while canonical is a direct translation from a truth table. Thank you for watching this video demo.